Some rocks in space are not just passing by, they are still on the books. A few have dates, odds, and names attached to them. The strangest part is that one of the most famous close calls was ruled out, then became more terrifying for a different reason. 2024 RF10. Imagine a fireball tearing across the sky above you, bright enough to rattle windows. That is the realistic concern with 2024 RF10. A small asteroid estimated at 8 to 18 meters across. Its possible impact date is September 7, 2092, and its highest listed probability is 1 in 155, with a cumulative probability of 1 in 130. Those odds are notable, but they describe an uncertain orbit, not a forecast. Traveling at 14.21 kilometers per second, the asteroid would probably break apart in the atmosphere. The Torino Scale rates the threat at 0, meaning no unusual public danger. Its Palermo Scale is -3.59, far below the level of concern. Track the number, but keep the scale in view. Small does not mean harmless, and it does not mean apocalypse. 2023 VD3. The strange part is the mismatch. 2023 VD3 sits at the top of the European Space Agency list by maximum Palermo value, yet its Torino Scale rating is 0. That ranking reflects a statistical comparison, not a forecast. The object measures between 11 and 24 meters across. Its maximum listed impact probability is 1 in 425, or approximately 0.235% on November 8, 2034. At 21.01 kilometers per second, an impact could produce a violent atmospheric explosion with a thermal flash and pressure wave felt across a wide area. You would be watching a Chelyabinsk scale event, not an extinction scenario. Its Palermo value is -2.67. More observations may erase the risk. The next asteroid has a longer observed orbital arc, and that changes the calculation. 2000 SG344. On ESA's July 23, 2026 Risk List snapshot, 2000 SG344 has the highest cumulative impact probability on the near-term table. Discovered by Linear on September 29, 2000, it is small, but it moves through a strangely familiar lane. Its orbit keeps almost the same solar rhythm as Earth, with a period close to 1 year, so this is not a distant rock making one clean flyby. ESA estimates it at 27 to 60 meters across. The listed highest risk date is September 16, 2071. The maximum single date probability is 1 in 1,117, and the cumulative probability is 1 in 354. It would arrive at 11.27 kilometers per second, with Torino Scale 0 and maximum Palermo Scale -3.18. Chelyabinsk was smaller. This could still turn daylight into a pressure wave. 2022 AE1. For a few tense weeks, the Palermo Scale placed this object near the top of the watch list, with a rating of around -0.66. Discovered on January 6, 2022, by the Mount Lemmon survey, it measured about 70 meters across. A possible impact on July 4, 2023 could not yet be ruled out. Then the follow-up window closed. Sky geometry and moonlight hid the asteroid from view, so you were left with a warning built on incomplete observations. The uncertainty lasted until the European Southern Observatory's Very Large Telescope recovered it. New measurements erased the impact possibility. No collision was coming. But for a while, a 70-meter rock, seen only through a narrow slice of data, had turned a scientific watch list into a countdown. 2024 YR4. 2024 YR4 crossed the line that gets everyone in planetary defense to sit up, an impact probability above 1%. Dr. Kelly Fast at NASA helped trigger the international alerts after Atlas in Chile found it on December 27, 2024, with December 22, 2032 on the danger board. JWST then measured the asteroid in infrared light at 53 to 67 meters wide. Put that over a city like Chicago, and you are not talking dinosaurs. You are talking Chelyabinsk scaled up, shattered glass, damaged buildings, and a local disaster you would feel block by block. Then the sky answered. Each new observation tightened the orbit. The Earth impact corridor slipped away. JWST also erased the moon scenario, leaving a pass about 13,200 miles from the moon. No significant risk remains, and that is the lesson. Detection worked fast because it had to. 2007 FT3. For 17 years, the scary part was not what telescopes saw, it was what they could no longer see. On March 20th, 2007, The Mount Lemmon survey in Arizona found 2007 FT3, a roughly 300 to 340 meter asteroid. Astronomers tracked it for about 1.2 days, then it slipped out of view. That short arc left the math with too much room. A virtual impactor means exactly this. The orbit cannot yet rule out Earth. One listed date was October 3, 2024, with NASA putting the chance near 1 in 11.5 million. Tiny odds. Still, you notice them when the rock is wider than the Empire State Building is tall. Later solutions reached toward 2068. A hit by a body over 300 meters could cause regional to continental destruction, and an ocean strike could drive tsunamis onto distant coasts. The danger was not a prediction. It was an unanswered trajectory. 2004 VD17. Worse still, this one briefly carried odds near 1 in 1,000, attached to a rock about half a kilometer wide. Discovered on November 7, 2004 by the Linear Survey in New Mexico, it entered the risk list as a serious object because size changes everything. Estimates put it roughly 500 to 600 meters across, large enough for a collision to become a global concern rather than a regional disaster. The worrying date was May 4, 2102, and early calculations placed the probability between about 1 in 1,000 and 1 in 1,600. In 2006, it reached Torino Scale 2, rare for an object this large. That did not mean impact was expected. It meant the math still allowed a meaningful danger. Follow-up observations erased that path, but the next case begins with far less certainty. 1979 XB. In December 1979, a faint moving point crossed Palomar's photographic plates, then vanished before a second observation could nail its path. That was 1979 XB, a large near-Earth asteroid with an orbit built from too little data. 46 years of silence since. ESA now puts it at 400 to 900 meters wide, with a possible impact date of December 12, 2056. The maximum listed impact probability is 1 in 4.27 million, while the cumulative risk is 1 in 1.36 million. If it ever arrived, it would hit at 27.54 kilometers per second. Torino scale, 0. That 0 is technically correct, because Torino weighs probability as well as consequence. But if the upper size is real, you are looking at flattened cities and coastlines hit by basin-wide tsunamis. Low odds, not low stakes. 101955 Bennu. Then comes Bennu. Its date sits far down the calendar, September 24, 2182, far enough to feel unreal and close enough to calculate. ESA gives its maximum impact probability as 1 in 2,702, about 0.037%. The Palermo Scale rating is minus 1.59, below background risk. Now add the object itself, a 484-meter asteroid arriving at 12.68 kilometers per second. A hit could carve a crater many kilometers wide, devastate the region around you, and push huge quantities of dust and vapor into the atmosphere. The NASA spacecraft OSIRIS-REx spent more than 2 years studying Bennu, collected material from its surface, and brought the sample capsule home in September 2023. We are not just tracking this one, we are holding part of it. 99942 Apophis. Apophis is not a sample you can seal in a capsule. It is a mountain with an appointment. Discovered on June 19, 2004, formal designation 99942 Apophis, it became a planetary defense stress test within days. In 1 week of December 2004 tracking, early solutions gave it roughly a 1 in 37 chance of hitting Earth on April 13, 2029. Its peak calculated risk reached about 2.7%, earning Torino Scale 4, the highest ever assigned to an asteroid. Better observations erased the feared impacts in 2029, 2036, and 2068. Apophis is about 340 meters wide on average, with a long axis at least 450 meters. In 2029, you will watch it pass about 20,000 miles above Earth, closer than many geosynchronous satellites. NASA has ruled out every charted keyhole through 2116. The needle misses. The warning did not. 29,075. 1950 DA. Unlike the last object, this is not an airburst problem. A single photographic plate caught it in 1950, then silence for half a century. When astronomers recovered it in 2000, the orbit suddenly mattered. The ESA Risk List estimates 1950 DA at 1,300 meters across, with a possible Earth impact on March 16, 2880. That is nearly 9 centuries away, so every prediction has to survive deep time. Even thermal radiation, the Yarkovsky effect, can nudge its orbit by centimeters per year until centimeters become continents. The maximum listed impact probability is about 1 in 51,020, or 0.00196%. The listed speed is 17.99 kilometers per second. Palermo Scale, minus 2.13, low risk. But a hit could excavate a crater tens of kilometers wide and push the sky itself into the harvest.